When it comes to forecasting, we often take it for granted that there are tried and tested techniques which have been tested for generations. However, one person that didn't have this luxury is our guest today, Spyros Makridakis, who, as one of the forefathers of the industry, actually invented many of the techniques which we use as standard. Today, we're going to learn a little bit more about his career and what we can learn from over 50 years of experience in the industry. So Spyros, thanks very much for joining us live from Cyprus today. As always, we like to start off by sort of learning a little bit more about our guests. So perhaps you could just start off by telling us a little bit more about yourself.
Well, as you know, I have been at INSEAD for a long time, and that's where I started working on forecasting. And then I left INSEAD when I retired 15 years ago. And here I am in Cyprus now in the University of Nicosia, continuing. And I know your company has participated in both the M4 and the M5 competitions, which are something I have been organizing for the last 40 years. So you know what is my contribution, how the M competitions, which are standing for Makridakis Competitions, have affected the industry of forecasting and the companies and the academics that they're using the findings.
Brilliant. So we'll get on to kind of discussing a little bit about the M5 competitions a little bit later. Maybe in the first part, we're going to look back at maybe sort of the last 50 years of forecasting science as we kind of know it. Seems we have quite a lot of ground to cover today, Johannes.
Yes, I mean, what is interesting is that when I founded Lokad, when I was, I would say, going through the motion of creating the company in 2007, at the time, there were still people that were, I would say, that were heavily skeptical about the very idea of a statistical forecast of any kind. And it was very strange because obviously at the time I was myself wondering whether I should actually continue my PhD in machine learning that I had started, never completed by the way, at the time, or if I should actually go ahead with Lokad, this project. And when I applied to a first startup incubator, the first time I applied, my application was rejected because there were two people in the jury that were on, I would say, that held very firmly the belief that basically statistical forecasting was just complete bullshit. And so you see, it was like, it was literally, no, we don't accept startups where the business plan is basically to sell divinations. I mean, there is no question that you can make money with divination. People have been doing that for ages. But are we okay with the idea that such a company would actually enter the incubator? The answer was a firm no. But the funny thing is, it was pretty much, I would say, the last generation. I think during the decade or so that I've been running Lokad, I don't think that there is pretty much anybody left in this industry that is holding this belief. So it's very funny. It was literally science in action. It's just science progress as just people retire. And but I believe that your contributions and the Makridakis forecasting competition have been really a key element to, I would say, normalize this field as far, in terms of scientific undertaking. It was becoming like normal science and no more like fringe science anymore.
It's interesting what is happening in Texas right now. The supermarkets are completely out of any goods. Nobody can find to buy food and a lot of essentials. And when they talk about forecasting, I tell them, look, you are surprised in one time, in a very long time, that you cannot find what you want. But think of all of the other times that you go to a supermarket and you find what you want to buy. And supermarkets, they have millions of items and they make a forecast for each one of them. So when you go, you find what you want. And this is a big advantage, and this is a big contribution of forecasting that we don't realize. Companies like Walmart and Target, they forecast weekly millions of items. So when consumers go, they find what they want to buy. And when there is not enough, like now in Texas, then they get very surprised. But actually, this proves how good forecasting is, because all of the other times they can find what they want in the great majority of cases.
Yeah, absolutely. And Spyros, kind of the forecasting as we kind of know it has been shaped in many ways by kind of the work that you've done. And perhaps you could just sort of take us back to when you sort of started out, maybe as a sort of a young student. I mean, what was kind of the landscape when you were first starting out as a young student?
Well, it was not like a young student, but like a young professor, that we did the first study about how well or how accurately the different forecasting methods can predict. And what we found surprised the statisticians of the time. And when I presented the results of that in London in the Royal Statistical Society, everybody was attacking me that the reason we found this type of results was because we're not very experienced in doing forecasting. And we found two results that they were very surprising at this time. The first one was that very simple methods were more accurate than sophisticated ones. And the other finding was that if you combine more than one method, the results, the accuracy was improving. And that was anathema for the statisticians of that time, that they believe that you can find the best method, and the more sophisticated, the more accurate it will be. And for each series, there's an optimal forecasting model. And both of them have been proven through the M competitions now that they're not correct. And as a matter of fact, now the new techniques that they use deep learning, they forecast 500 different models, and then they take the median of them, and that they find to be the best forecast.
Absolutely. And Johannes, sort of the M5 competition is one we kind of took part in not so long ago. The M obviously standing for Makridakis. What does that kind of M5 kind of competition mean to you from maybe from a vendor perspective?
So, I mean, obviously that's, so the M5 competition is kind of fun. I mean, it's one of those few, I would say, globally recognized events where people are trying to compete on skill for once, you know, just unlike I would say trade shows, where it's mostly about marketing. And the most interesting thing is that in the top 100, you know, companies, so companies that arrived, it was there was two I'm not going to go too much into the detail. There was two sides of the competition, the classic forecasting side, the quantile forecasting side. Lokad only took part to the quantile part of the competition, and we arrived sixth. But the interesting thing is that in the top 100, no matter whether you were looking one side of a competition of the others, none of our biggest competitor was present, which was surprising, because what they sell is forecasting. So first we have like a massive disconnect between what happens when you do an actual, you know, test, and what are the typical, I would say, market shares that you observe in this market. So that there is this thing that is, well, that's just the way it is. And then, so that would be my first remark. And then another thing where I'm bouncing back on the remark of Professor Makridakis on the simplicity is that we achieved to land, you know, position number 6 out of 909 teams on the quantile side, but we used a very simple model. We used just a very plain parametric model, 3 cyclicities, you know, day of the week, beginning, end of the month, week of the year, and this was it. And we used ESSM. And the interesting thing is that we were within, you know, 1% accuracy of the best, which was best model was using gradient, basically gradient boosted trees with a massive data augmentation scheme. But the interesting thing is that we are using not only, I would say, something like 0.001% of the complexity. And so I think that there is something that is quite remarkable. Is indeed, first we have, in terms of science, it demonstrates that very simple method can be very powerful. And that also, I believe that was also another element of the competition, is that I would say accuracy in the classical sense is not the only elements that matter, that you can have other dimensions to the forecast, and that's really what those probabilistic forecasts are about, is that you want to have a better understanding of I would say, of the structure of the uncertainty itself. And that's also something that we at Lokad, we have been working very, very hard for almost a decade now.
You're right. In the first 3 M competitions, we found that simple statistical methods were more accurate than sophisticated ones. In the M5, we found that simple machine learning methods were more accurate than sophisticated machine learning methods like deep learning. Because practically not only you, but practically all of the top competitors in both the accuracy and in the certainty challenges use simple machine learning methods, and they found that they were the most accurate and the most effective in predicting the Walmart data.
And one of the things that's really interesting about kind of the M5 kind of competitions is everyone's using these computer-based forecasting techniques, and that's now standard across the industry. But if you look back to when you were starting out, Spyros, starting out as a professor, that was kind of before maybe the dawn of computers. So how did the introduction of computers change the way you were doing things? What kind of opportunities did that give you?
Well, the opportunities is that stay simple. In forecasting, there are 2 parts. One is to fit what happens in the past, which is the easy thing. And what, before we started the M competition, was happening, they were overfitting the past, thinking that the future would be exactly like the past. There was not, now there's the idea of separating the forecasting data into a training part and to a testing part. So we try to predict as accurate as possible, not the training part, but the test part, the future, in other words, because the future is not exactly like the past. It changes. And the idea now is we don't want to overfit the past, because there will be some changes between the past and the future. So we try then to figure out how these changes are going to take place and use them to predict more accurately the future. And this is a very big difference, because in the past, they were not considering, they were thinking that the future would be exactly like the past, but we know very well that it's never happening.
Yeah, and would you agree with that, Janice? I mean, how have you seen sort of forecasting techniques kind of evolve through the decades, if you kind of look back?
Yeah, I think what Professor Makridakis is pointing out is, I think, is fundamental. There is this kind of apparent paradox, is that you want to be accurate on the data that you don't have. That's something very puzzling when you think about it, because you naturally, obviously, whenever you want to measure the accuracy, by definition, you're going to measure the accuracy against the data that you have, but this is not what you want to do. And this problem has been, I believe, partly addressed by the very end of the 20th century with basically the theory of Vatnik and Chavonenkis. But it's a very, very abstract theory that gave birth to the support vector machines that are very, very complex. But that was basically, they started to formalize the idea that you have essentially the empirical error and the structural error. And the structural error is, and basically the idea is that if you want to minimize the real error being defined as the error that you're about to make on data that you don't have, you need to basically minimize both the structural error plus the empirical error. And you can only have some kind of a lower bound, and that's really what those support vector machines are about. I mean, support vector machines are very theoretical perspective. I mean, they have been implemented. They did enjoy great successes as a machine learning techniques in a couple of fields. But I think the most important contribution was to clarify from probably a more theoretical perspective what was going on. And then when you want to actually, get real results, I think resorting to those competitions where you really held back a part of the data for real is probably just a way to go in terms of, in order to have, I would say, a very clean methodology.
So how does the approach you kind of take in kind of a test scenario, which is very much competition based, vary from what you kind of would be doing in the real world?
I mean, in the real world, you have access to all data all the time. And that gives you this strong, I think, methodological bias that Professor Makridakis was pointing out, is that it's incredibly tempting to just have something that is going to fit the data. You know, it's...
Yeah, that's what they used to do in the past. The famous Box-Jenkins methodology was to fit as well as possible in the past. And that's what it was losing over the simple methods, that they were not fitting very well in the past, but they were predicting more accurately in the future. Because if you overfit, then you're losing the essence of forecasting. Because the future is exactly like the past, and the future is never exactly the past.
Exactly, and one of the puzzling, example was when I started Lokad was clients were usually super surprised when they were looking at an incredibly erratic time series, time series that just go up and down. I mean, for example, the consumption of alcohol in hypermarkets, that's one very erratic product with spikes. And then when we would be doing, classic forecast during the first few years of Lokad, we are not doing probabilistic forecast yet. We're doing classic forecast. And for those super erratic time series, I would show a forecast that was, I would say, much smoother, than the original time series. And most of my competitors, they were able to exhibit, forecast time series that were as erratic, exactly as erratic as the original time series. And clients were, and I went into many great debates with my with my prospects, they were not yet clients, who just did not believe that this super smooth forecast could be correct, because it was so unlike the historical time series that was super erratic and spiky, while my competitors were showing, very, very spiky, were able to show and put on display very, very spiky forecast that just looked like the historical data.
So Spyros, one of the things I'm really curious about is how kind of the perception towards forecasting has kind of changed throughout your career. I mean, when did that shift towards forecasting being seen as kind of a science kind of happen, and when did it become very much kind of more accepted into kind of the mainstream?
Well, it took some time. In the beginning, the classical statisticians, they used to do the same thing that they were doing to you when they were telling you that what is important is to follow the fluctuations of the series, but that's not how you forecast. So it took some time to realize that we cannot predict randomness. And what the M competitions have proven beyond any doubt is that what is important is to separate the past from the future, and that you don't try to overfit the past, but you try to have a model that is adaptive to changes from the past to the future. And that's the major change. And now it's accepted that in addition to looking at forecasting, we have to look at the uncertainty in our predictions. That a lot of people don't like it at all, because psychologically it's not a very good thing to talk about uncertainty, to say that I'm going to forecast, but I'm going to also to tell you how inaccurate your forecast would be. And in particular, and you will know that when you go to clients, they tell you tell me two things. You tell me you are going to forecast, and you tell me that you cannot forecast, because there's a lot of uncertainty in what you tell me it's going to be the future. But that's reality, and you cannot avoid being realistic.
Yeah, and it introduces this kind of idea of a confidence level in your kind of forecast. I mean, Johannes, would you say that the perception has almost shifted so far that people almost expect too much from forecasting and they're expecting it to be infallible?
I mean, that's an interesting question, because you see, I went to quite a few times to the NRF trade show. That's a National Retail Federation trade show in New York. Normally that happens in January, and what I saw is that most of my competitors, again, I'm sorry to be tough or maybe slightly biased. I mean, excuse me with that, but But basically, they were very frequently making completely outlandish claims of having 99% accuracy in retails. And frankly, for example, where I say it's ridiculous is that I don't even know what 99% accuracy mean in an hypermarkets where most products are sold like 0, 1, or 2, or maybe 3 units a day. So 99% accuracy would mean that you would know most of the days exactly to the last unit whether somebody is going to pick a product, while this person might not even know themselves, if they are about to pick it. What I've seen is that there were many vendors that were trying to, I would say, to really oversell it, this idea that you can have those incredibly accurate forecasts everywhere, which is absolutely not the case. And then, to use, I would say, the aura of science that statistical forecasting has gained in some other, areas such as, demographics, electricity consumption, water consumption, areas where the amount of uncertainty is comparatively very low, and basically to jump, to make a leap and say, well, we can do exactly the same in, for example, in an hypermarket, which is just not quite the same. You can do a lot, but it's not the same order of magnitude in terms of accuracy.
And one of the biggest problems with forecasting users is their expectations. It's too high because consultants try to sell them forecasts that they're overconfident. And this is one of the biggest problems. So part of what we have to do in the field, try to say, look, we're not prophets. Our data, in particular in things like retailing, tell us that the uncertainty is very big, and we have to do something about this. And we don't talk about only the normal uncertainty. We have also uncertainty which is fat-tail ones, the famous Nassim Taleb, that destroys a lot of our forecast and creates a lot of problems. Like the pandemic now, it has created a lot of fat-tail uncertainty. We must take this also into account. We cannot avoid uncertainty.
Yeah, Johannes, would you kind of agree with that? We've spoken a bit in the past about kind of consultants coming in and promising a little bit, probably too much from forecasting.
Yes, I mean, that was also what was actually hard about probabilistic forecasting was not the technicality of producing probabilities. This is not that difficult. What was hard was indeed to convey the acceptance that, yes, Lokad was going for probabilistic forecasts, not because our forecasts were crappy. I think we are, even if we are not necessarily the best in those competitions, we are certainly not, we are ranking quite high. The problem was not that we had crappy forecast, and it was to have an acceptance that there are things that are beyond our control. And the interesting things about those tail events is that suddenly you have something where it's very, very difficult to trust your data, and that's where that's something where it is frankly a very high interest to me, is that by keeping your, I would say, non-tail forecasting model simple, is that you have something where you can, with, I would say, obviously a degree of subjectivity, but if you have a simple, relatively simple and manageable forecasting model, you can inject structural priors to basically inject this dose of super rare and super extreme events. So, and that's basically what we are doing at Lokad, is that, for example, things like pandemics, we can't forecast pandemics. But what we can do, and that's not even super complicated to do, is to say, well, we can, I can, inject a prior to say there is one chance, a yearly probability of 2%, let's say, that there will be, a 50% downturn that impact the company. I don't know why. I just know that it's a reasonable assumption. It's subjective. Why 2%? Why 2% every of a 50% downturn? All of that is very subjective, but the interesting thing is that if you inject a dose of I would say, of tail events in your forecasting models, even if it's fairly inaccurate, in terms of the quantification is very vague, what happens is that when you build your supply chain optimization on top, you steer the decision toward things that are a lot more robust against those tail events without, investing too much money on it. So that the interesting thing is that, and that's the sort of things that we do, is that we keep those forecasting models simple so that we can inject, those of structural priors that are, I would say, very much made up, although they are reasonable. They are not, precise. But the consequence of that is that you can have, at the end of the day, supply chain decisions that end up to have, I would say, that end up a lot more resilient with regard to things that happen infrequently, and the process is quite simple, and but in practice it takes a lot of convincing to basically to bring people to understand those black swan. Indeed, I frequently resort to please read the work of Nassim Taleb. But it's a tough sell when you want to convince a prospect that you want to give them 600 pages books written by yet another great Greek thinker of Nassim Taleb, and to convince that about the importance of dealing with those fat tails.
So Spyros, we're going to have to sort of start bringing this to a bit of a close. But if you kind of look back, I won't give away your age, but over the last half a century where you've been involved in the industry, what is it that you're kind of most proud of when you look back at kind of your career?
Well, that we basically provide empirical evidence about what works in forecasting and what doesn't work. And it's not to just talk and say what's going to happen, is to say, look, we have done these experiments, because the M competitions are experiments. And from these experiments, we can tell you that these things work and these things don't work. And what we can tell you is that simplicity works, because simplicity realize that there's a lot of randomness in what has happened in the past, and we cannot predict precisely. And because we cannot predict precisely, we have to understand that all our forecasts are uncertain. And because they're uncertain, there is risk, and we have to do something to anticipate this risk and believe that it exists, and to do something to be prepared to face the risk.
Absolutely. Okay, we're going to have to wrap it up there, but thank you both for your time today.
Thank you very much.
Thanks also for interviewing me.
That's everything for this week. Thanks very much for tuning in, and we'll see you again in the next episode.